Hi, welcome back. This is the second part of the GS 170 lesson. Last time, the first week lesson was about the general overview of the computer. So we established the meaning of a computer and what it is for, why it is so the important in modern life, etc. like that. But today we'll talk about one of the most important component known as computer hardware. So for those, please read the chapters 2 and 3 of our textbook. That will give you very much more detail than I can cover in this time period. So we'll talk about the main unit issues and the CPU and memory, I/O devices, communication devices, and putting together into a box, that kind of orders. So more or less that what is in the hardware of a computer system. Maybe a short review of a previous session may be helpful to make the connection. We said that the computer is an information processing system. In other words, that what does computer do? It processes information. Information, that's facts and ideas. So we want to change our knowledge or use up our knowledge for good purposes. So this is a system. Because of we said it's a system, that means it's a multiple component working together for a single purpose, that this system is composed of hardware, software, and the users, and the data to process, and the procedure to use the computer. So also that one point we made last time is that the computer is the main force in third industrial revolution. Right now we are in the fourth industrial revolution, first being in steam engine, where all this power comes from steam, and then second generation is from electricity. So that revolutionized all the production and operation system of a whole industry and society. And then around the 1970s and 80s, that computer arrived, and this caused the third generation industrial revolution, and it really changed our lives. And the fourth generation, the industrial revolution, is right now in making. So hopefully we can talk about that someday. Then why the computer is so important, so much powerful, and needed in every aspect of our lives. That I said the nice acronym being SAVER, SAVER, so speed, accuracy, volume, then efficiency and repeatability. So the first three items of this advantage, that is very fast and very accurate, and handles a huge volume of information that is controlled by or depending on the hardware, and then efficiencies and avoiding repeating the same thing over and over again, that can be achieved by software component. Then it is pretty important that you have some better understanding about the computer, and hopefully that this course helps you. I told you last time that the relevant material, including textbook, syllabus, and these PowerPoints, the materials and some other references, is found in web. Actually, it's not a web, but it is a Google Drive. So what you can do is that you can type the HTTPS. You don't have to that. The bit.ly/3dslphh. This is just making very long address very short, usually called URL shortening. Maybe we can talk about that later, or by clicking this QR code up here, that by clicking this you can get this the directory accessed, and from there you can download or open the files that is relevant to this course. Okay, so let's embark to the journey of today's lesson of a hardware component. Again, hardware component is very huge. In other words, there are so many new hardwares always designed and marketed, and it is sold. So almost impossible to trace every new product. But at least that I want to give overall pictures, and as time goes on, you can get used to some of those hardware components that you will need for your own purposes. Okay, so first of all, we can make some kind of a classification. Like I can say, well, hardware is hardware, true, but you can group them into 3 or 4 groups. Here I put the 4, but actually last 2 are kind of same category. So first one is processor. That's the brain. So computer does all kind of wonders of information processing. That is actually done by these processors. It's more like cooking. When we are talking about the cooking, it's more like actual cooking process. So the processors. Then there are the different all spectrum of those devices known as storage devices. In other words, that data, that information must be stored somewhere. Sometimes we need that one temporarily, or sometimes we need it permanently. So the storage devices, there's many different spectrum that you will also find out in a minute. And then I/O devices. So in other words, that computer is a kind of a black box, something that does wonders. So we put some kind of information in there and expect something back. Here's our human. So well, computer is the tool for human benefit, and we got to give something or give an instruction and get some results out. If we want to have some analogy to this kind of concept, is that it's like when you're driving a car, you start the car and then change the gear and push the pedal. That kind of input you do. It's more like instruction or some guidance to the machine called the car. Then the car will respond according to preset rule. So when you push the pedal deeper, then it'll go faster. If it's less, then it'll go slower. And if you step on the brake, it'll stop. That kind of action you are giving, that is input. And the results of moving, stopping, the accelerating, those things are more of an output. It's not computer does this with the information, so it's not as the obvious as the car driving, but nevertheless there's a lot of the analogy of input and output of those actions. Then the network devices, that is that we want to make a connection. So in other words, that here's my computer, or then there's your computer. So usually we can work alone, but that's not enough. So we want to make that one be connected and connected and connected. Of course, by what are we connecting? By some kind of a data or information passing around. So in a sense, that's the input and output, so I/O devices. But the network devices are quite much different from typical I/O we are dealing with. So I prefer put that one separate category as network devices. So we'll give that four different big categories. So here is a CPU. It says CPU. I will say that one, but CPU is one of those processing units. C for central, so central processing unit. But some kind of this processor. Then there's a memory interacting. This is a storage device. Then I/O devices. So the input brings some kind of information to the memory, the storage temporary location. Then our processor gets in and out, and then take there's some results and give back to output devices. Sometimes I make an analogy as the cook. This is a cook who's cooking the very nice food. Then this is the kind of shelf or some kind of storage location in the kitchen. Then this is the material like flowers and meats and eggs like that. So it is coming in and that's put it on the shelf or the counter. Then the cook with his or her hands, then making some kind of the cooking process. Sometimes it's temporarily, so you have a half done thing while you got bantered some flour. That one goes to another separate location for storage. Then they take it back immediately, and then they take it out to the you finish the cooking, and the final food will be taken out. So that kind of input output, and then a processor who's doing actually some work done, that's a cook. And then this is a shelf where all the material, the raw material to cook the materials are placed or stored. So there are four groups of the hardware units that I want to point out. So in general, that within a box, of course, there are bigger computers, much different architecture, but you have monitors and speakers, keyboard. So these things are typically on input devices. The keyboard and the mouse, those things are input devices. And there are something more. I don't have every devices in here, but there's some of those units. They're like a RAM is a memory, CPU. What is a CPU? That's actually the processor, and the processor has to do a lot of work. So you need the fan to cool it up. Then you got to have one big board that push all together so that it can run faster and more efficiently. So that one is called the main board, or sometimes called the motherboard. And then some other device, device driver, that is the CD-ROM or hard drive like that. Then we need you need the power. You need the cook of the kitchen need some strength by eating food, something. So you need the power, electricity. Of course, the computer will run without the power supply, whether it is a house current or industrial current or battery powered. So there are all those things into the one big box. So we usually call this one as a main unit, and there's a case in there. Okay, so let's continue on. So here's a whole array. This is a very small. Actually, there are more, but this one is just some picture of hard drives. That's the storage devices. And then there's the main memory. This main memory is the more of the faster and the quicker but temporary storage location. And then there are processors on here. And then the processors need some kind of a case or socket. And there's all those bunch of connection plates. These are connecting what? That's I/O devices. So there are so many locations that needing connection. That connection, the site is called the port. You know that there's an airport and the seaport. That's airport, for example, is the kind of location where the people can come and stay, or so it's a more of an entry point and sometimes go out. So those in and out of those the data coming in and out, I/O device connection. So all the I/O devices are separate devices. So obviously we need have that one and be connected rather than running by itself. So we'll see how what I mean in this situation. Let's continue on. So processors, this is a brain, I said. It's a brain of computer. Does all the work of data processing or do all the work of cooking, if you want to call it. And there are many types of but there are not just one type, but many things that as long as that unit is doing some kind of thinking, some kind of data processing activities, then it needs some form of processors. So in general, there are so many, it's much more complex. So it's to simplify the explanation, but there's arithmetic and the logic unit, ALU. So what this one does is that do some calculations. Actually, computer does, hardware does very simple calculation, but different type of adding is subtraction. And the different type of addition, or you multiply, you do same addition over, that's multiplication. And then you subtract many different times or different form, that's the division. Then there's the multiplication over, that's power. All those mathematics can be done from very simple the operation, and then combine those simple operation into more sophisticated operations. So usually the processor's calculation unit is very simple, but it does very fast, and it can be branched out into much more complex form, the calculation form. Then there's the address unit. What does address unit is that, remember that the processor must interact or interface with the storage area. So it is more like you are picking up certain data from the storage area, and sometimes more than one of them, and do some processing and put it back somewhere. So you got to know exactly where you are taking from, and you are taking in, or they are storing into. So that kind of exact address location, the location pointer, that address unit is also important. So the CPU, after all, is very simple in a sense. Individual, the action is simple of the simple calculation and the simple decision that I said the logic unit is doing some decision. Should I do this one? Yes, or no, I shouldn't do that. No, that kind of logic unit. And then where do I get the data? And then do some kind of changes and put it back like that. So the CPU, regardless of how expensive, how fast it is, that internally is very simple, but made it more sophisticated so that it does all the wonders we know of. So there are many different types, you'll see in a minute. So most important is the central processing. That's the headquarter. So whole system, there's a one headquarter of the processing unit that controls the overall operation, and that's all the calculations and all the necessary the action. But once in a while, CPU need help. Like when you are getting a lot of data from other devices, that the speed is slower. So it is, instead of CPU doing every time that slow the process catch up. Let them do their own work, and when enough is done, then bring it back. Then another good example is that when you are processing imagery, like you have a background for your windows, or in the Zoom there's the virtual background, it should process that graphics. Graphics is a very hard job in a sense that there are a lot of calculation needed. Individual pixel, that one must be addressed, and they gotta be worked on for changing the color, changing the sizes, and when it had to be animation, some kind of changing of the whole picture, then it's even more operation. So let that be done by own processor, just to do the graphics thing themselves. So here, then another one is that when it goes to the connecting the other computer or the modem like that, then data must come in and out, in and out. In the case that those networking is another complex operation, you need a traffic controller of that the network trafficking of the data coming in, usually called signal coming in and sometimes go out. So that one being taken care of by its own processors. So CPU is the main one and they're more expensive and faster and the more the capacity it has. But there's some helpers that they are other processors. So CPU and then another thing that I want to say is a CPU in old days was a big box with a very complex circuiting. I'll show you a picture in a minute. Then, but they somehow the technology changed it, and they could put all that complex circuit into one small chip. So that one, the one CPU on one chip is called a microprocessor. Then old style is almost gone. So now that the microprocessor and the CPU are interchangeably be used, and it is used for small size but still large size, and newer designed computers of large size still has the own box of CPU. CPU is not one chip but whole box. Then besides CPU, there are different types of process known as something like what I said, graphics processing unit. So GPU, network processing unit, NPU, sometimes the peripheral processing unit. That is that there are many things are connected to. That one is a peripheral unit. Peripheral means central and outside the surrounding area. That's peripheral. So sometimes it's called the PPU. You don't find the PPU very much these days, but old days that was pretty important processing units. So that the purpose of this one is helping CPU. So let the CPU, the precious the resources being focusing on calculating complex job and do fast. And as a matter of fact, that you may know or may not, but these days one CPU contains more than one processor. Sometimes there are 4 processors or 8 processors like that. So that's called and just a 2 it can be. So it's a dual core, so or quad core. So core is what the main CPU unit, and you duplicate same unit 4 times or 8 times and let them process. So when there's only one cook, it may take much longer, but if 4 cooks working, then it's faster, obviously. So that's the processor. Most important, the objects. So here, this is all the box of CPU. There are so many wires, and there's a lot of transistors and diodes and the some kind of connectors like that. Here's a human being, so you can see how big is this CPU. So CPU box, or the CPU is in a big box and very complex and very expensive. Actually, typical CPU in around the 1960s, 70s, even 80s, they cost in millions of dollars. Then whole thing shrunk into very small chip. So you may have heard about this i7, i5, and the i9. This i9 is most advanced one. So this contains inside it, depending on the version, that the 4-core or the 8-core, usually go by the power of 2, or the dual core like that one. So some computer looks the two computers look exactly the same and doesn't seem to be much different, but it is one computer is more expensive by several $100s. Why is it? What kind of a CPU you are using? Intel and AMD are two the most famous and flourishing companies that generate creating this the CPUs or microprocessors. This diagram itself is that actually it is designed that it is given a name of VLSI, that is a very large scale integrated circuit, or even they are further than ULSI, that is a ultra large scale integration. You integrate so many things in one chip. So each of those distance is now really like a nanometer. That's the 1 billionth of a meter size, very small. So this one's blown up in huge size. And actually later on, I'll say that one, but some portion of them, I think is this part, is own memory that exists, but there are a lot of those circuits that are making those the calculation and addressing units. So once this one is made, then you put this one into the circuit, and then you make it's more like that. Then you put the cover, and there's a socket here. You just plug it in. There are many legs depending on the model. There are quite a few legs in here, and you push it in. So then it will generate a lot of heat. So it has its own fan cooling like that. So when you look at the computer, in case that you can open it up, then you will see that the biggest chip, or the most prominent member of a whole unit is this CPUs, or the microprocessor there. Okay, so that's the processor, many very important, or actually it's a main actor of the sort of information processing. Then besides that, which one the other component, which are the other components? The storage devices. So we got to store. Computer needs main types of storage device to store data. So there are some of them are permanent, some of them are the temporary. So this is the device hold the data permanently and inexpensive. So it is you create the data and you don't want to throw it away, and it's so precious. You know, modern days that the real value is created by creating data. So data is very expensive to generate. So they are stored in hard drive, hard disk, or CD or flash drive. You have those thumb drives. So then old days there was a tape or the paper was used, but not anymore. And definitely that is a secondary storage, that is that permanently done and in the second separate unit. Sometimes that hard drive can be inside the box, but they are separate unit always. So when you're assembling it and then you are worried about your security or your information, then you can just pull out those hard drive, then that's your information. All the other information, other component doesn't have any information that's any use. So storage devices are located in the separate unit, and the main memory is stores data temporarily during the processing, and that's directly interacting with the CPU. So usually it's residing inside the module called the DIMM. Actually, our book talks about that DIMM. It's not that important to know this one, but I'll show you. Unfortunately, when I'm recording this one, I cannot flip the forward or backwards, so I'm just not showing you and come back. But DIMM, dual inline memory module. There's a little chip that containing memory devices, and you put many of those, and that one set it into the line. So that's called the DIMM. I'll show you the picture, then it's much easier. Then sometimes it is too long, the size is pretty lengthy, so I'll make it shorter. So that's called the SO-DIMM. So SO stands for small outline DIMM. By the way, when in the computer system, you once in a while you hear about the form factor. The word form factor is that the size of it. It's just the size of it, the dimension, how length, width, and the height, how long, how big it is. So that's a form factor. Especially like a laptop and the tablets, that the space is so cramped, so you want to make your component as small as possible or as narrow. If an individual unit is small, then it's easier to push it in. Then, so this kind of a main memory is called random access memory, so called RAM. There's another word called RAM, read-only memory. So sometimes some of the operating system informations are stored in the RAM, but that's not erasable. But it's not used for the processing. It's just some program coming from there. So all the data processing, the storage is in the RAM. So random access memory, and it's usually called DRAM, dynamic, because once it is stored some data, what you turn off the computer, then it is erased or it is become junk, like that one. There are some static RAM, but that one is used for storing data, but it's expensive, so we are not worrying about it. Then SDRAM, the synchronous DRAM. So synchronous DRAM is that I don't know. What it has is that the computer has its own clock. So that clock is generating some pulse, and each operation is following that pulse. But if a calculation cannot catch up with that pulse, it may not be synchronized. But if every pulse of this cycle of this clock that you do one operation, then it is synchronous. These are briefly mentioned in the book, but it's not that important. So if you can understand and you know it, then or you can study further, that's a good idea. But it is not that essential, especially for using it or understanding the computer. So there's a single speed and there's a double speed, the DRAM, like that one. So there's a single speed, single data rate, or double data rate, that kind of thing. So which one is faster? Okay, then register. There's the permanent storage, like the hard drive or CD and the flash drive, like that. Or there's a main memory that is used inside the computer, or that there's the group of the memory that is inside the CPU. That's called registers. Just you don't have to know, because usually the register is not the concern of a general user, but just they know the name. That register is being used as a part of data storage for temporarily, but very fast and expensive. So here's some the example of this one is an old core memory. I just dig out those pictures from the website. good old days when I was working with the computer, then we used to use this kind of a memory. That is, it's a core. So one bit is inside there. It's one ring there. There's a ring, and there are two wires passing through, and that depending on how the electricity is coming in, then this becomes north side or south side, then makes 0 or 1, that kind of thing. So this is the memory. But now that, so this one takes just 1 megabyte, several megabyte only, but still this big. So that's the old days, not anymore. Then we have a modern computers like this kind of thing. So it's a dual inline. So usually this side and the other side has that, so dually, and the inline is like lined up, and the memory module. The individual box has a memory here, memory here, memory here, like that. So, or actually 1 bit, 1 bit, 1 bit, 1 bit over 8 bits, like that. So on the back side, this dual inline memory module, or the small outline DIMM, the dual inline memory module. So that's for much shorter. So compared to this one, it's shorter, and the size is almost that. I mean, this length is almost the same. So this DIMM memory is the big slot there. You just plug it in. So depending on the type of DIMM, and there you will see that the clock speed is the 15 nanosecond or the 20 nanoseconds, like that. So that's clock cycle synchronization. So with that, then you have those slots. You just plug it in, and usually there are 2 or 4 slots like that. So you can plug it in, 2 of them, then your memory will be suppose each one is the 1 gig, then you have the 2 gig of a main memory. All 4, then make a 4 gig memory. Or better yet, that you have this memory module that's 4 gigabytes, then just plug it in. Then you got a 4 gig of main memory. That's so when you buy a computer, that's talking about what is the RAM size. And then that is the capacity of a memory, how much memory you have in this main memory. This one is one more time, the directly interacting with the CPU, and this one any data stored in here during the operation is erased or become junk or garbage when the computer stops or you turn off the computer. So before you are done, you are turning off your computer, you must save these files into permanent storage. All right, then this is a secondary storage. This is a permanent storage. So you have seen this hard drive usually goes inside or sometimes goes external. The CD, and then this flash drive and the pen drive, and then the tapes, and the pen drive is called magnetic tapes, and this one is static the memory. So this one is used as a hard drive. This is very expensive. So there are many different type of secondary memories. Then I don't know how much I can cover on, but the information presentation is that I had this thing in the first the lesson, but I didn't get a chance to explain it. So in computer, every information is in binary number, either 0 or 1, and the bit is a binary digit. So one place where the value is either 0 or 1, and usually that gives only 2 choices, 0 or 1. So you put more of the of those bits, that makes 8 of them will become byte. And then you put 4 of them, that become 32, because each byte is 8-bit. The 32 bits become, they represent a number that actually maximum number is 4 billion something. Then there's a cycle-wise that input processing output like that. So you see those the input, processing, output, and the store, input, the processing, output, store, things like that, cycles. So I just gave that the little more explanation. If you have one switch of a 0 or 1, then if switches flip, that's 0 or 1. That's only two choices. But you got two switches side by side, then there are four choices. Both are zeros, 0, 0, or this is a 0, but this is on. Or the opposite, this is on, but this is off. Or both are on. So there's four choices. Then if there are three of them, you can try that out, but 0, 0, 0, 0, 0, 1, meaning that these two things are off, and this is on or off. There are two choices. Then now you put everything, the 0, 0, 0, then just to put this one as a 1. So 0, 1, 0, 0, 1, 1. So you have this 1 and up and down, up and down. You can repeat these four things with this either 0 or 1. So if you got three of those things, switches, then you got 8 choices. So 2 to the power of 3. 4 of them, that's 16 choices. You can actually count the 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0. You can try that on out. Then you will see there will be up to 16. So if it gets to 10, that's too much, so you cannot by hand. But anyhow, that becomes 1024, 1024. That is 1K of computer. So typically we know that 1 key, 1 kilometer, 1 kilogram, or the 1 kilo, the ton, like that. That's exactly 1,000. But in computer, 1 kilobyte, that is a 1024 byte, because that gives the 10 of those numbers. So everything is a power of 2. So that's just a little short lesson about the binary number thing. But someday we got a chance, and we can talk more about it. So here's the on and off switches, up and down, up and down. So if in this case there, we see that there are 8 of those switches. So all possible combination of which one is on, off, all possible combination at a time. Throughout the all possibilities, 0, 0, 0, 0, 0, 0, 0 to 1, 1, 1, 1, 1, 1, 1, 1. All those things will be 2 to the power of 8. This is 256. So you can easily calculate that one by multiplying by 2 many times. Okay, so inside the computer engine, that I said that this is the location for the CPU, and this is a slot for the hard drive. I'm sorry, the RAM. And then this is a connector for the output devices, and then input devices, and the graphics, and the audio, and then USBs, and networks like that. So there are a whole bunch of those peripheral device connectors here, and there's a CPU there, and the memory here, the other control there. There's a lot of control here. So this whole thing is called motherboard or main board. So some people, even sometimes you can plug it in this plug instead of a memory. You can plug it in. Actually, I should say that this is where the DIMM memory switch is going here, and this is expansion card, so you can have a graphics card and the network card being installed too if we want. So in the case this one, sometimes called this daughter, DAUG, daughter board. So holding is the mother and the daughter. Why there is no son and the father and the son, I don't know, but that is a mother and then daughter board, like that. So anyway, that whole thing, many components of hardware work together to achieve some kind of the goal of processing the data. And then I/O devices is that you got to put something, so that's a devices tool for communicating between human and the machine. You don't know what's going on inside the box. You don't see it, it's electron, and you don't feel it, you cannot write it down. So what you need is somehow you visualize it, or you can get what is happening, the results of those data processing from some sound or some other display or some other pattern. So you need that kind of a interfacing with the human beings. That's what this computer is for. It's for human. So allow human to give instruction to machine. That's input devices. And then output devices include the monitor, speaker, printer that you can either visually or audio with your ear that know what is going on inside or what kind of result you have from there. So just to take a look at that input device and output device, it can easy to understand that there's some microphone that also be part of the input devices. So you just say to the microphone, then you will know what is going on there. Then there are more varieties of those, the trackballs and the webcams, then microphone, digital scanners, and the game control, and then there's a digitizer, I said. Then there's the barcode scanners. Those things are used for input. So put some information to computer so that it can be processed. Of course, one huge source of information coming from is from hard drive. Another huge information coming from is network card. But here, typical things that nearby to see it are those kind of things, and still there are many coming up. Then this is output devices. There that is you see by visual the display, and by sound or printed paper, or some kind of a monitor here, or speaker here, or webcam. Webcam usually is an input devices, but at the same time that they can also be, they have a speaker here, and you can communicate with the webcam only. So that's being used once in a while as the output device also. Okay, so just please know that there's a processor who does all the main job, and the main memory and the secondary storage, that's where all the storage is done, data being stored. Main memory is temporarily storing the data during the processing, but when power's off, then the contents will be erased or lost. So you need a way of saving that into the permanent drive or permanent storage devices. Then network drive devices is that you got to connect throughout the whole world. So being connected all world like that. So there's a thing called the hub, switch, router, bridge, and there's a gateway and the repeater, and the NIC card. That's the network interface card. That one is your computer, inside your computer, that sometimes wireless, or this with Ethernet cable connected to wired, that connecting. This is for your computer, but these are those things that interfacing and interconnecting. I will talk about this, the differences and what they are doing when we are covering this network part. So anyway, it's responsible to connect the computer to other computer in the world, all over the world. And as I told you that third generation industrial revolution being computer, then there, not only this computer itself that we now see here, but it's also the internet is a very important the component, and that made it successful. So make sure that we have a good understanding our networks. And there are many shapes of or the devices that relate to network the operation. So I just have some pictures like important thing is a network connectivity, connection. Connection. We must connect, especially when everybody in this pandemic, nobody sees each other. So through the computer, we're not connect with the others. That's the network does. So conclusion, computer hardware is the electromechanical device doing all the data processing, and it is processor, storage devices, I/O devices, and communication devices. And hardware is getting faster and cheaper, and continually new products are developed and marketed. So catching it up is another of the our duty to know that what kind of new devices are available. Okay, I think that's all. So I'm stopping my talking here, and hopefully that this gives you some idea about the hardware picture. And I try to cover all the necessary part, but it is not that easy. So please read chapters 2 and 3. There are some more pictures and some more details. And another thing is that when you are dealing with the computer, there are so many acronyms. The abbreviations. So it says NIC. Then what is it? It's a network interface card. Then DIMM. What is it? So that's the dual inline memory module. So if the difference between professional and the non-professional is that familiarity of these acronyms, and some of them you are using all the time, some of them you don't. So CPU, for example, is a so frequently used word, so you must know central processing unit. And there's a network cards, and the I/O devices has a lot of those abbreviations. So try to familiarize yourself about those form of the acronyms, and that will be helpful for understanding and dealing with computer tasks. Okay, that's all, and thank you.